examples. First of all, what is a surd, right? So we need to know what a surd is. If I ask you to square root 25, well, you will get a really simple answer. You will get 5. If I were to ask you to square root 9, you would simply get 3. But what if I told you to square root 6? Let's try that on our calculator. The square root of 6. The square root of 6 gives you 2.4494, and it goes on forever. This is what we call an irrational number. It goes on forever. Now, dealing with irrational numbers can be really annoying. So, which one would you prefer to see? 2.449 go on forever, or would you prefer to see the square root of 6? I have a good feeling you will just prefer to see the square root of 6. So what is a surd in very simple language? Well, a surd is an irrational number, but you leave it in terms of square roots. So this here is your surd, the square root of 6. All right, because surds make irrational numbers a little more easy on the eye. Okay, now that's a really simple explanation of what surds are. All right, so before we move more into surds, I just want to point out a few common sense, well, not really common sense, some things that should have been learned in indices. For example, if I have the square root of a multiplied by the square root of an a, and both of them are the same, did you all know the square root of a multiplied by the square root of a will just give you back a? Make a mental note of this. This will make life really easy. Also, if I have the square root of a multiplied by b, all right, I don't really need to put the multiply there, because if I don't put anything, a multiply is understood. So, did you all know that this is the same thing as the square root of a and the square root of b? It comes like both of them get separated and they get their own square root sign. The same thing goes for a divided by b, and there's a huge square root sign holding them hostage. Did you all know this is the same thing as the square root of a divided by the square root of b? All right, these rules where each of them get their own individual square root sign only works for multiplication and division. It does not work for addition and subtraction. And just to clarify, right, if I had a, b, c, this means, well, all three of them are being multiplied. You can rewrite it like this. Don't worry, as I do the questions, I'm going to remind you of these rules over and over till it sticks in your head. All right, so let's start out with some questions here on surds. Let's start out with the most basic set of questions. All right, let's say someone will, if I told you I had 2x plus 4x, I think you know the answer to this. It's just simply 6x. Why? Because both of them have an x. They have similar types of letters. So if I had the 2 plus 4, but instead of x, I had the square root of 3. Could you add these two items? Yes. Instead of x, both of them have the square root of 3. So this would just simply be 2 plus 4 is 6. And instead of putting x, you just simply put the square root of 3. A lot of students don't see the comparison, like how these two are so similar. So I'm just pointing it out to you. It's going to be very helpful in the questions. All right, so let's start off. Questions. This is questions type 1. Right, so A. All of these questions are going to be simplify. I'm going to ask you to simplify all of these questions, and you're going to pretend that you don't have a calculator. But I know in the exam you will have a calculator, but you just for the examiner and for your working, you're pretending you don't have a calculator. But you can use your calculator to double check your answers, or to do small calculations just to make sure that you actually divide or multiply correct in your head. So let's say that you have 8, and they ask you to simplify the square root of 8 plus the square root of 2. And let's say you lost your calculator and you don't have a calculator and you need to simplify. Well, did you all know that 8 is the same exact thing as 2 multiplied by 4? So the 8, we can break it up into 2 multiplied by 4. And we still have what here? The square root of 2. Now remember, these two items are being multiplied. So I can rewrite this using this rule. Remember, if we have A multiplied by B and a square root sign, we can split it up into square root of A multiplied by the square root of B, where both of them get their own individual square root sign. So we can break this up into the square root of 2 multiplied by the square root of 4 plus the square root of 2. All right. Now you will notice something. If you try to square root 2 on your calculator, you will get an irrational number. So it's best to leave it as the square root of 2. Same thing here. But we all know the square root of 4 will not give us an irrational number. In fact, the square root of 2 is just simply 2. All right. And we have this here. Now, 2 multiplied by 3 is the same thing as 3 multiplied by 2. It doesn't matter which order you multiply. So when I square root the 4, I get the 2. But there's a multiply here. I'm just going to put the 2 in front, so it will look neater. So I'm just going to put the 2 in front there and remove this. So how do we do this question now? Remember, if I have 2x plus 1x, what would be my answer? Won't it be 3x? So you see how this has a number in front, but this one doesn't have a number in front? Won't the number 1 be understood? Instead of x, I have a square root of 2. Instead of an x, I have a square root of 2. So 2 square root of 2's plus 1 square root of 2 will give me 3 square root of 2. This is my final answer. And I dare not square root 2 and multiply by 3, because the square root of 2, you can try it, will give you a long irrational number on your calculator. So that's E. Let's try another question. All right. Part, this is B. All right, let's simplify the square root of 12 plus 2 square root of 3. You're going to realize that in most of these questions, the bigger number, you're going to have to split it up into 2 numbers. For example, 12 is the same thing as 4 multiplied by 3. And don't forget we have 2 multiplied by the square root of 3. This and this have the same value, because 4 by 3 is 12. So according to this rule, we can split up the 4 and the 3 and give each of them their own individual square root signs. The square root of 4 will give us a nice number, 2. And then we have the square root of 3 plus 2 square root of 3. Right. So it comes like we have 2x plus another 2x. But in place of x, we have the square root of 3. So 2 square root of 3's plus our next 2 square root of 3's will give us 4 square root of 3's. And you dare not square root 3. I guarantee you, if you square root 3 and try to simplify it, you'll get a crazy number. The only time we apply the square root sign is when we know we will get a very nice number. All right, let's try another one. C. All right. C, where is it? Where is it? Okay, here we have, let's try division one. Let's try the square root of 24 divided by the square root of 3. All right. I believe there are two ways we can actually try this question, right? So let me just make sure. All right. There are two ways. I'm just checking the time on the camera. Right? Everything is going good. The easiest way to do this question would be to apply this rule. Remember, when we are dividing two items and we have one big square root sign, the top will get its own individual square root and the underneath will get its own individual square root. So this is like this, and what we can do is erase both of these, right, and put one big square root sign. We all know 24 divided by 3 is 8. So when we divide 24 by 3, the whole thing reduces to 8. And we need to simplify 8, the square root of 8. Believe it or not, we can simplify this further. 8 is the same exact thing as 4 multiplied by 2. Now we apply this rule. The 4 gets its own square root, and the 2 gets its own square root. The square root of 4 is 2. The square root of 2 will not give us a good number. So leave it like that. So this is one way. Now remember the answer we have here. I'm going to try to work this a different way and see if we get the same answer. So make a note of this answer. Remember, this was the original question. The square root of 24 divided by the square root of 3. Let's say we do not apply this rule. Let's leave him with his own square root sign, and let's leave the 3 with his own square root sign. And let's see if we can get the same answer. 2 multiplied by the square root of 2. All right, so 24 is the same thing as 12 multiplied by 2 or 8 multiplied by 3. It's a trial and error here. Let's try this one here. 24 is the same thing as 8 multiplied by 3. And don't forget the big square root sign. And we have a square root of 3 on it. I bet that we can apply this rule to this. The 8 will get its own square root sign. The 3 will get its own square root sign. And you're going to divide it by the square root of 3. This and this will cancel off, leaving you with the square root of 8. And we previously saw that 8 is the same thing as 4 multiplied by 2. Apply this rule again. The 4 gets its own square root, the 2 gets its own square root. The square root of 4 gives you a nice number. Square root of 2 does not. We got the same answer, working it a different way. All right, that's C. Let's try a next one. Let's try D. All right. D. All right, I'm seeing this one here. The square root of 20 plus the square root of 45. Believe me, if you square root 20 on the calculator and you square root 45 on the calculator, you will not get a good number. It will look terrible. All right, so let's see what happens here. Let's try to break up these numbers into two numbers. Anytime you're breaking up numbers into two numbers, for example, this is just a rule of thumb. 20, there are plenty numbers we can replace this with. 2 multiplied by 10, 1 multiplied by 20. This is a stupid choice though. 4 by 5. Okay, so there are two choices, I believe, here. Okay. Whenever you're doing this, make sure one of the numbers can be easily square rooted. So, can we square root 2 and get a good number? No. Can we square root 10 and get a good number? No. Both of these will give you crazy irrational numbers. But if we choose 4 and 5, I know that 4 is really easy to square root, and I will just get 2. 5, on the other hand, will not give you a nice number. You just need, when you make your choice, try your best to get one of the numbers to be easily square rooted. The other one just won't be easy to square rooted. Don't have both numbers being crazy when they're square rooted. Don't. Make sure one of them can be easily square rooted. So 20, I believe 20, the correct choice is 4 multiplied by 5. And for 45, we need to break up 45 into two numbers. All right. 45. 9 by 5, I believe it's, I don't know why I'm 9 by 5. You would think I'm a maths teacher. I think 9 by 5 is a really good choice. 4 can be easily square rooted. 9 can be easily square rooted. Both of them will get their own square root sign. Both of them will get their own square root sign. So let's rewrite it like this. Well, there's no need to put that there. All right. So let's see what's going on here. Square root of 4 is 2. The square root of 5 will give you an irrational number. Plus the square root of 9 is 3 by the square root of 5. Notice both of them have a square root of 5. They come like an x. So 2 square root of 5s plus another 3 square root of 5s will give us 5 square root of 5s. That's the final answer for this particular question. All right. D. Let's try E now. E. All right. I'm hoping this is getting easier and easier. 5 square root of 18 plus the square root of 72 minus the square root of 75. Now, to be honest, this is the first time I'm actually doing this question. So I'm going to be working it through just like how you might be working it through as a first timer. All right, let's try to break up all of these numbers into this. I'm going to use different colors here. All right, let's break up this 18 into something. 9 by 2 is 18, right? 9 is easy to square root. The 2 is not easy to square root. So that's a pretty good choice. What about the 72? Boy, what number? 9 eighths. Well, I think 72. 9 by 8 is 72, right? So that seems to be a good choice. 9 multiplied by 8, because 9 is easily square rooted, but 8 is not. At least one of them is easy to square root. And 75. I think a good choice is 25 multiplied by 3. 25 is easy to square root. 3 is not. So at least one of them is good. So what's going to happen here? Everybody over here, we're going to apply this rule here. So we're going to end up with 5 square root of 9 square root of 2 plus the square root of 9 multiplied by the square root of 8 minus the square root of 25 and the square root of 3. Okay? Right. So this is easily square rooted, easily square rooted, easily square rooted. All right. So let's go. Colors again. Square root of 9 is 3. So let's write this here. So when you square root the 9, you get 3. The 3 can be immediately multiplied by the 5. So 3 by 5 is 15. And you have the square root of 2 here. Plus the square root of 9 is 3. So we put 3. And we have the square root of 8. Then square root of 25 is 5. And then we have the square root of 3. Now, this may look like the end of the question, but I guarantee you this has an extra step in it. Let me just clear some space here. Let's move this around. You're going to realize that everything here is not completely simplified. 8 can be broken up into two numbers where one can be square rooted and one cannot. Remember, 8 is 4 multiplied by 2. So if we apply this, the 4 will get its own square root sign and the 2 will get its own square root sign. So you see the extra step there? But the thing about it, the square root of 4 is 2. And this 2 will get multiplied by the 3 to give us 6. So it will look like this. 15 square root of 2. 2 by 3 is 6. Don't forget the square root of 2. Minus 5 square root of 3. You notice these two items have a square root of 2. He's the odd one out. He has a square root of 3. So let's add up these two. 15 square root of 2's plus 6 square root of 2's will give us 21 square root of 2. And then we just have this minus 5 square root of 3 hanging around like a weirdo. This is as simple as this question will get. Alright, so that was E. I hope you understood that. If you didn't, rewind the video and watch it again. Alright? Right? These are standard questions that will come in your maths exams. Right? Let's try. Can't remember if it was D or E. Losing track. Let's try F here now. Let's try 2 square root of 45 plus the square root of 20 plus the square root of 32. Here's what to do. I really recommend that you pause the video now. Right? So pause the video. Right? And work this out and see if you're going to get the same answer as me. All right? So pause it and we're going to pretend that you did, and I'm back now. So let's split up these numbers here. Here we have 2 and the square root of 45. Let's try to break up 45 into 2 numbers. Plus, we're going to break up the 20 into 2 numbers. Plus, and the 32 into 2 numbers. I know I keep saying this thing over and over, but make sure when you break it up, one of the numbers can be easily square rooted, and the other one just simply won't. So, 45. 9 by 5 is 45. Right? 20 will definitely be 4 by 5. 32. 32. What 2 numbers can be multiplied to get 32? 8 by 4 is 32, right? Or how about 16 by 2? That's a good choice. 16 by 2 is 32, and it's really easy to square root 16. The square root of 16 is 4. So that's a good choice there. Right, so let me write this back. Remember, everybody here is going to get their own square root, own square root, own square root. So it's going to be 2 square root of 9, square root of 5, plus square root of 4, square root of 5, plus square root of 16, square root of 2. Square root of 9 is 3, square root of 4 is 2, square root of 16 is 4. 3 by 2 is 6, square root of 5. We just have a 2 square root of 5 here. And we have 4 square root of 2. Both of these have a square root of 5. 6 square root of 5 plus 2 square root of 5 is 8 square root of 5. And the 4 has a square root of 2. These two cannot be squished together. This is your final answer for this particular scenario. All right, so let's try a different type of question now. Okay. All right. It's simplification again, but the questions are going to be laid out slightly different. Okay. Okay. E. Remember, this topic is useful in maths and in advanced, right? You need it for both. So let's try to simplify 2 square root of 3 plus 2 square root of 6. No, sorry, it's a multiply. Divided by 4. Let's try this. Well, we have a little problem. Nothing. Well, the only thing I can see here is the first step. We can probably, since it's a multiply, you can say 2 by 2 is 4, right? Let's see. Let's go forward and see how this works. 2 by 2 is 4. And we have a square root of 3 being multiplied by the square root of 6. And underneath is 4. Right? Just in case you didn't, well, we're going to apply the same rule where A multiplied by B, where each of them will get their own square root sign, but we can work it backwards, right? The 4 and the 4 will cancel out. Square root of 3 multiplied by the square root of 6, I believe will be the square root of 18. But we know that 18 is 9 multiplied by 2. Each of them will get their own square root sign, and the square root of 9 is 3. And we just have the square root of 2 after. All right? So that's the answer for this particular question. I'm going to show you a different way of getting the same answer. We're going to pretend that we're going to take from here. So the 4's got cancelled out. So we had the square root of 3 multiplied by the square root of what? 6. Now look at this carefully. I'm going to make the square root sign a little bit longer. 6 is the same thing as 3 multiplied by 2. So that means both of them are going to get their own individual square root sign. And we have the square root of 3. Remember this rule? The square root of a multiplied by the square root of a. Once both of them are the same and you have a square root sign, you just get what? A. The square root of 3 multiplied by the square root of 3 is just what? 3. And then you bring down the square root of 2. You get the same answer. Two different methods, same answer. All right, let's try another one. B. All right, just checking the time to make sure. All right, everything seems to be going good. B. Let's try the square root of 12 multiplied by the square root of 27, square root of 8 multiplied by 2 square root of 6. Let's try this question here. All right, let's start breaking down these numbers into two numbers. One that can be easily square rooted and one, well, will not be easily square rooted. So 12 is the same thing as 4 multiplied by 3. 27 is the same thing as 9 multiplied by 3. 8 is the same thing as 4 multiplied by 2. And well, we just have a 2 and a square root of 6 here. I could break up this 6 into 3 multiplied by 2, but I'm not going to do that as yet because it's not easy to square root 3 and it's not easy to square root 2. Both of them will give you irrational numbers. So let's leave it like this for the time being. We're going to apply the rule. Both of them are going to get their own individual square root signs. So let's write it in. Its own individual square root signs. Right. So let's simplify what we can simplify. Square root of 4 is 2. Square root of 9 is 3. Square root of 4 is 2. So on top we get 2 square root of 3 multiplied by 3 square root of 3. Underneath we have 2 square root of 2 multiplied by 2 square root of 6. Let's see what happens here. We're multiplying. So 2 by 3 is 6. And the square root of 3 multiplied by the next square root of 3 will just give us 3. Remember, I'm just going to say it one more time. The square root of a multiplied by the square root of a will give us 8. So if it's square root of 3 multiplied by the square root of 3, you will just get back 3. So on top we get 6 by 3, which will give us 18. I will write it just now. Let's multiply the underneath. 2 by 2 is 4. And the square root of 2 multiplied by the square root of 6. So you have the square root of 2 multiplied by the square root of 6. I'm not going to do anything there for the time being. All right? Right. Let's see. I'm going to try to leave everything here as I'm trying to avoid decimals. 2 could go into 4 and 2 could go into 6 3 times. So on top we get 3 by 3 is 9. 2 square root of 2 and 6. All right. I'm running out of space here, so I'm going to come here. So we have 9 divided by 2 square root of 2 and square root of 6. I just wrote it here. All right. Now is the time, I think, to split up the 6, because I think this could get a little bit simpler. 6 is the same thing as 2 multiplied by 3. And we know he's going to get his own square root sign, and he's going to get his own square root sign. So it's going to look like this. The square root of 2 multiplied by the square root of 3. Now we have a good situation here. Look here. Look over here closely. All right. So the square root of 2 multiplied by the next square root of 2 will give us 2 square root of, this is this 2 here, sorry. Square root of 2 by the next square root of 2 will give us another 2. And then we have the square root of 3 waiting there. Right. Run out of space here. Right. So we have 9 on top and we have 4. 2 by 2 is 4. And we have the square root of 3. All right. I really believe this is as simple as this question could get. I don't think we can get it any other way, right? Unless, but I won't do this in the exam, but I'm not too sure. But what I'm about to show you is mathematically correct. 9 is the same thing as 3 squared, and we have 4. And remember, the square root of 3, square root, is the same thing as to the power a half. Because both of these have the same bases and we are dividing, remember that's permission to minus the powers. So the 4 will stay underneath and then we will get 3. 2 minus a half, because we have to minus the powers because it's a division, is 3 to the power 1.5. Right? Personally, I feel this is as simple as this will get. This looks a little more complicated. But I just use the excuse to show it, to remind you of the indices rules. All right, so I'm going to show you how to expand brackets now with Surds. Well, expand and simplify. So it's two things you're going to do. All right, so question type 3, expand and simplify. All right, so let's write down the first question. Let's say I have the square root of 2, and in brackets, I have the square root of 3 plus the square root of 2. All right. So everyone inside the brackets gets multiplied by the item outside the brackets. So if we were to expand this, we would simply get the square root of 2 multiplied by the square root of 3. And then we have to say plus the square root of 2 multiplied by the square root of. We're going to leave this as the square root of 2 multiplied by the square root of 3. But the square root of 2 multiplied by the next square root of 2 is just simply 2. Remember, the square root of a multiplied by the square root of a will just give you a. Well, that's a really simple example. Let's try a slightly harder one. Try this one here. 4 square root of 3, open brackets, the square root of 2 minus the square root of 3. Let's expand these brackets. Remember, everyone inside gets multiplied by the blue item outside. So it will look like this. 4 square root of 3 by the square root of 2, that's when you multiply these two, minus 4 square root of 3 multiplied by the square root of 3. Right, there's not much you can do over here, but the square root of 3 multiplied by the square root of 3 will give us normal 3, and 3 by 4 is 12. So this is how my final answer will look. All right, I don't think I can simplify that any more, right? Some people might say, well, we put a 4 here. Remember this rule? Well, I've been saying it over and over. They might just merge these two together and say, when you have two separate brackets next to each other and there's a multiply in between, you can merge the two numbers together and put one square root. So 3 by 2 is 6. to me, I'm not too sure which one is simpler. I would have stopped the question here. Some people might actually put that. All right. Let's do some more examples. Okay, this should be C. We're going to expand double brackets now. Okay, let's say we have the square root of 2 plus 3, open brackets, and then we have the square root of 2 minus 5. Remember how we expand double brackets? We look at the first bracket, we block the second item, multiply both of them by the square root of 2, then block him, and then multiply the both of them by 3. And then we try our best to simplify the scenario. So let's pay attention to this first. So we're going to block this guy out here, right? We're just going to block him out. He doesn't exist. We're going to multiply both of them by the square root of 2. So it's going to look like this. The square root of 2 minus 5, and both of them get multiplied by the square root of 2. Now we're going to block him. Then we're paying attention to the 3 now. But then we're going to say plus 3, and in brackets we're going to have the square root of 2 minus 5. Multiply this out, and we try our best to simplify. Square root of 2 multiplied by the square root of 2, by now you should know it's 2. Square root of 2 by 5 is just, well, I'm going to put the number first. 5 by the square root of 2 plus 3 by the square root of 2 is just 3 by the square root of 2, and 3 by minus 5 is minus 15. All right, let's simplify the scenario. We have a 2 here and we have a minus 5. They have no surds attached to them. 2 minus 15 is minus 13. And here we have minus 5 square root of 2 plus 3 square root of 2. Both of them have a square root of 2. So they come like an x. Minus 5 plus 3 is minus 2. And don't forget to put back the square root of 2. Then let's do that again. Minus 5 plus the 3 will give us minus 2. And then we put back the square root of 2. All right? So that's the final answer for this particular question. All right. All right. So let's try another example, D. All right. Let me see if I can give you a trick question that usually comes in the exam. All right. So for D, we have 5 square root of 10 minus 10 square root of 3. And this whole thing is squared. Now, do not make the mistake and square everybody inside the brackets. Squared simply means you have to take the brackets and multiply it back by itself. Right? It's a really common trick they play on you. So here's what we're going to do. It's the same process as before. What we're going to do, we're going to block one item here. I really wish I brought something to block. So we're going to block him, multiply both of them by the 5 square root of 10. Then we're going to block him and multiply both of them by minus 10 square root of 3. All right, so let's try that. So, well, let's block him and let's actually put the work in. Sorry, if I put this here, it's going to block the board. Let me fold this here. All right. So let's see this. We have 5 square root of 10, that's him. And we're going to multiply this by 5 square root of 10 minus 10 square root of 3. Block him now. And we use a different color. Minus 10 square root of 3. Open brackets. 5 10 square root minus 10 square root of 3. So let's take our time now and multiply this out. Remember, if we have two same things being multiplied and they have a square root, the square root of 10 multiplied by the square root of 10 is just simply 10. So I'm going to try to do this. Let's see. 5 by 5 is 25. And the square root of 10 by the square root of 10 is just simply 10. 5 by minus 10 is 50, right? 5 by 10 is 50. Don't forget your minus sign. And then we have the square root of 10 multiplied by the square root of 3. Great. Let's use a different color here. Let's multiply out the blue scenario. Minus 10 by 5 is minus 50. And then we have the square root of 3 by the square root of 10. Now the square root of 3 by the square root of 10 is the same thing as the square root of 10 by the square root of 3. So I'm just going to put the square root of 10 by the square root of 3. Minus 10 multiplied by minus 10 is positive 100. When you multiply two negatives, you get a positive. And the square root of 3 by the square root of 3 is just simply 3. Right? So let's simplify this. 25 by 10 is 250, right? And 100 by 3 is obviously 300. These two do not have any surds in them, right? So we can add these two here. 250 plus 300 is 550. Now look at this. This may not be obvious. Look at this. Both of them have a square root of 10 and square root of 3. So this comes like an x. If I told you minus 50x and I minus a next 50x, I will get minus 100x. But instead of an x, the common element, you're going to put the square root of 10 and the square root of 3, right? Minus 50 of these minus a next 50 of these will give you minus 100 of, well, I guess those. All right? So I really hope that you understood this example. The next thing we're going to be doing is something called rationalizing the denominator. Okay? Right, and this is like the final thing I have to teach you in Surds. So this one is type 4 questions, rationalizing the denominator. All right, what does that mean? It means I'm going to give you a fraction, and the fraction, the denominator, will not be a nice number. It will be a surd. We need to get rid of the surd in these types of questions. Okay, so let's start with a really easy example. A, I want you to rationalize this. It's 2 divided by the square root of 3. Now here's something that may not be obvious to you. If I have 4/5, let me write that neater for you. Do you all know that whatever you do to the top of a fraction, you're allowed to do it to the underneath? If I decide to multiply the top by 2, not a problem. I just have to multiply the underneath by 2. I will get 8 on top and I will get 10 underneath. But if I simplify this, I will still get back my 4/5. All right? So by multiplying the top by a number and multiplying the underneath by the same number, you do not change the value of the fraction. Okay? So we're going to apply that concept here, and that's allowed in maths. So here's how you rationalize the denominator. Right now, the underneath, the denominator, is a surd. We don't want the denominator to be, I spelled denominator wrong. I put denomination. It's denominator. Alright, sorry about that. Oh, I don't know if it's an O or E. Who knows? Alright, so here's what we're going to do. All we have to do is multiply the top by the surd and multiply the underneath by the same surd. So 2 multiplied by the square root of 3 is just 2 multiplied by the square root of 3. But we know the square root of 3 multiplied by the square root of 3 will give us regular 3. You notice that the underneath is no longer a surd. Let's try another one. B. I want you to rationalize the square root of 3, and the underneath is the square root of 15. Alright. First of all, we should know that this could simplify even before we begin to rationalize it. we have the square root of 3, but 15 is the same thing as 5 multiplied by 3. So you should be able to do this one now. We have the square root of 3. Both of them, since it's a multiply, will get their own square root sign. And what will happen here, and you notice there's a square root of 3 on top and a square root of 3 underneath. So you cancel that off. So we end up with 1 divided by the square root of 5. Cool. So when there's an opportunity to simplify it and they ask us to rationalize it, simplify it first. And afterwards, we will rationalize it. The underneath is still a surd. When you are rationalizing the denominator, it means that the underneath must not be a surd. So what we do, we take the top, we multiply it by the surd, but we also are obligated to multiply the underneath by the surd. Doing this will make the fraction look different, but it will not change the value of the fraction. 1 by the square root of 5 is just the square root of 5. The square root of 5 multiplied by the next square root of 5 is 5. All right. So I'm going to show you how to rationalize a fraction now when the underneath has more than one items. Right now in this example, it only had one item as a denominator, and over here it only had one item as a denominator. I'm going to show you what will happen when there's an addition and subtraction. Addition or subtraction as the denominator. All right. So let's try to rationalize this one here. 5, and underneath is 5 minus the square root of 3. You notice there are 2 items underneath. Now pay attention to this pattern. When we rationalize it, we have to multiply the top by something, and we also have to multiply the underneath by something. It just has to be the same exact thing. Look at the underneath number. There are 2 items. Just look at the second item. The second item is negative. All you have to do, you're leaving the first item alone, and the second item, you make it the opposite. You change the sign. So if it's negative, just make it positive. And you have to do the same thing for the underneath. And if you were to multiply out this scenario, you will have the underneath will change to a nice number. It will no longer be an irrational number. So let's do this. The top gets multiplied by 5. I should put this in brackets, and I should put the underneath in brackets, and I should put this in brackets to show I'm multiplying this whole thing by 5 and this whole thing by this whole thing by this. So let's see. Top 5 multiplied by 5 is 25, plus 5 multiplied by the square root of 3 is just 5 multiplied by the square root of 3. The underneath now, this is where we block this one and we multiply both of them by the 5. And then we block him and multiply both of them by minus 3. So let's try that. I'm going to block him. 5 by 5 is 25. 5 multiplied by the square root of 3 is just 5 multiplied by the square root of 3. Then we block him. Remember, this number is minus square root of 3. Minus square root of 3 by 5 is just minus 5 square root of 3. We can't do anything much there. And let's do the next one here. This minus square root of 3 gets multiplied by the positive square root of 3. A negative and a positive is a negative. But square root of 3 multiplied by square root of 3 is just a next square root of 3. You will notice what will happen in the underneath. Here you have a positive 5 square root of 3, and here you have a negative 5 square root of 3. They will cancel out each other. So on top, we end up with 25 plus 5 the square root of 3. This disappears, and now we have 25 minus 3, which is 22. You notice the underneath is a nice number now. It's no longer an irrational number. All right, so I really hope that you understood this example. Let's try one more. All right, D. All right, let's try one. Oh, here's a good one. Let's say we have 1 divided by the square root of 5 minus the square root of 3. minus 1 divided by the square root of 7 plus the square root of 5. Okay. Whoa. This is a hard question. What would you do in the exam if they gave you this? Okay. First of all, you would and they ask you to rationalize the whole situation. You need to rationalize this one separately, rationalize this one separately, and then minus the both of them. All right? So that means on top, we are going to multiply it by, there are two items here. Just look at the second item and you make him the opposite. So it will be the square root of 5 plus the square root of 3. So we're going to multiply this by this. And underneath, we're going to multiply this by the square root of 5 plus the square root of 3. The same exact thing. Okay? And it's, on top here, we're going to apply a similar process. Looking at the underneath number, the second number is positive square root of 5. So we're going to multiply the top by the square root of 7 minus the square root of 5. We're only changing the second item, and we're obligated to multiply the underneath by the same thing. Right? Remember, we're multiplying this whole thing by 1. So make sure and put your brackets to remind you what's going on here. You get a really, really complicated. Alright, so what we're going to do, multiply anything by 1, you get back itself. Underneath, well, you know what to do. Block him, multiply both of them by the square root of 5. Block him, multiply both of them by the square root of 3. Alright, this is a really, really long example. So let me write this in pieces. This could get really long. Alright. 1 multiplied by anything is itself. And now we have to multiply both of them by the square root of 7. And now multiply both of them by the square root of 5. Right. Now a question like this won't come in normal maths. It will come in additional mathematics. Alright, so all we have to do now is take our time and multiply everything out, and well, most likely all the denominators, all the surds or irrational numbers will just disappear. Alright, so let's see. Square root of 5 by the square root of 5 is 5. And the square root of 5 by the square root of 3 is just the square root of 5 by the square root of 3. Minus the square root of 3 multiplied by the square root of 5 is the square root of 5 by the square root of 3. Oh, well, there's a slight mistake here. Negative and a positive is a negative. The square root of 3 multiplied by the square root of 3 is just 3. Let's do the same thing across here. Alright. Square root of 7 by the square root of 7 is normal 7. The square root of 7 multiplied by minus square root of 5 is just the square root of 7 square root of 5. Plus the square root of 5 multiplied by the square root of 7 is another square root of 5 by the square root of 7. This and this is the same except one is negative and one is positive. A positive by a negative is a negative. The square root of 5 by the square root of 5 is just 5. Right, things are looking good. These two cancel out. These two cancel out. So underneath you end up with 5 minus 3, which is 2. And over here is 7 minus 5, which is 2. Alright, I need the space on top here. Alright. So this question, the top is the square root of 5 plus the square root of 3 divided by 2 minus the square root of 7 minus the square root of 5 divided by 2. Right? So this transforms into this, what we can do now, well, we can add it as a fraction by finding the LCMs, and then we'll be finished. The LCM of 2 and 2 is 2. 2 into this is 1. Multiply the whole top by 1. Lucky for us, it's going to be the same exact thing. Now there's a little trick here, right? 2 into 2 is 1. 1 by the whole top. You multiply the whole top by the 1. But there's a minus sign here. This minus sign really belongs to the whole top. So when you multiply this whole thing by 1, you're going to get the square root of 7. And you might mistakenly put minus the square root of 5. But this minus sign belongs to the whole top. I know it looks like it only belongs to the square root of 7. But it belongs to the whole top. So a negative and a positive is a negative, and a negative and a negative is a positive. Sorry, a negative and a positive is a negative, and a negative and a negative is a positive. All right, so we're almost finished. Here we have the square root of 3 minus the square root of 7, square root of 3 minus the square root of 7, and you have 1 square root of 5, add a next square root of 5 is 2 square root of 5s, and this whole thing is divided by 2. And I'm very proud of myself for doing this very long question. All right, so this last question, its difficulty, it's a hard question, will only come in an additional mathematics exam, like I said. All right, so guys, I really hope that you enjoyed this topic on surds, and my next topic will be on logarithms, which will be strictly for the additional mathematics students. So take care.